Hi, this is Miss Ertl. This video is about solving for distance, displacement, and time using the formulas for speed and velocity. In a previous class, we solved for just velocity. Solving for these variables involves a little bit more steps or rearranging of the equation, and so I want to walk through that with you today. So D, remember, goes with speed. So D is something we solve with speed. Delta x, or displacement, goes with velocity. T goes with both. Now you can solve these all just using straight algebra, plugging them into the equation and solving for the missing variable like you would in algebra. But sometimes everybody's got different comfort levels with that. And so what I'm going to do is show you a quick and easy way to rearrange the equation beforehand, and you'll always get the right answer. So if I have the equation of speed is distance over time, I'm going to set up a triangle that looks like this. This division line right here represents the division line in my equation. So noticing that D is above the division line in the equation, I need to put the D in the top of this triangle. And in the bottom, I'm going to put a multiplication symbol, and I'm going to put V and T in the bottom quarters. It doesn't matter which corner, as long as they are both on the bottom. I can set up, again, a similar one for displacement over time. The only difference is going to be, what do I put in the top? I'm still going to put the thing that displacement, which is, again, related to distance, and then I'm going to have V and T on the bottom. The way that you use the triangle is that I cover up whichever variable I'm trying to solve, and what is left in the triangle shows me the math that I would do. So to kind of illustrate that, we start by looking at, well, if I wanted to solve for V, well, we already know that V is D over T. So if I cover up V, and I'm crossing it out since you can't see me covering it up, I'm left with D over T, which is exactly the equation that I want. If I want to solve for D, I cover it up. I am left with V times T. If I want to solve for time, I cover it up, and I'm left with D over V. You'll get similar things for the triangle using displacement and velocity, so that you would have delta x is equal to V times T, and T is delta x, or displacement, over V. It's easier, I think, to remember the triangles than it is to try to remember the different versions of the formula. So how would I use this? How far can a person run in 0.25 hours if they run at 16 kilometers per hour? What I always start with is looking at, here's my numbers and here's my labels, and what do those mean? Hours represents time. Kilometers per hour is a speed. So I'm finding how far is what is the distance. If I use the original equation, so I'll show you that way and then I'll erase it and show you the other way. I would plug in 16 kilometers per hour for for V. I would plug in D for D because I don't know D, and then I would put 0.25 hours in for time. If you're comfortable with math and comfortable with algebra, you would probably already realize that all I would have to do is multiply these two numbers by each other to get my answer. And if you don't know why that is, it's because to get this off the bottom, I would multiply both sides by 0.25. These would disappear. Multiply this side by 0.25 hours. And I will get a distance of, sorry, that is a terrible D, 4. What do I label it? I mentioned when we did the examples in class using speed and velocity that the reason I have you show your units is because what's left is how you determine what your label your answer. In this case, I have hours, and I have hours on the bottom of a fraction, so those would cancel out. So I am left with kilometers as my label. If we run this again, but using the rearranged version of the equation from the front, again, the rearranged version is right here. distance is velocity times time. Velocity is 16 kilometers per hour times the time of 0.25 hours. And if you think back to what we just did, this was the math that we just did using the other equation, using the original equation. You end up doing the same thing. It's just, is there a step in between or not for the rearranging? So I still get a distance of 16 times 0.25 is 4. Kilometers per hour times hours is kilometers. I get the exact same answer. So it really just depends on which way works better for you. If I'm going to now do a displacement instead of a distance, it says what is the displacement, so I don't know what the displacement is. I again would have a similar equation. I could use v equals delta x over t, or I can use the rearranged. I'm going to use the rearranged one. When we went back up here, delta x is v times t. Again, it looks just like the equation for distance, but with a different letter. So delta x is going to equal v times t. My choice in numbers are 1.3 seconds. It takes thunder 1.3 seconds to reach you, traveling at 330 meters per second east. Seconds is time. Meters per second east is velocity. So if I'm finding displacement, I would take 330 meters per second east times 1.3 seconds. 330 times 1.3, sorry, I have to get my calculator out, is equal to 429. So change in x is 429. My label, well, seconds is on the top of here, seconds is on the bottom, so I'm left with meters. And then I see I have this letter E for east. A reminder that you could also choose to put positive 429 meters, because east is considered a positive direction. Again, your choice, just like which way do you want to solve it versus which way do you want to label it. I will find, again, now if I'm going to solve for time, there's a little bit different because time is in a different part of the triangle. It says how much time would it take for a car to travel 325 kilometers at 72 kilometers per hour. Since there are no directions in here, I know this is a speed and this is a distance. Again, I can use the regular equation, but I will tell you right from the start that when students solve for t, that is the most mistakes that I see in terms of what do I do with these numbers now? Because we're not used to seeing the unknown variable on the bottom. I've seen people take 325 times 72, which does not get you the right answer. I've seen people take 72 divided by 325, which does not give you the right answer. And the reason is because first I have to get t off the bottom. So the actual first step of solving this is to multiply both sides by t, which gets t off the bottom of this side and onto this side. So I'm going to just erase that out of there so that you can see that by doing that, I'm left with t times 72 kilometers per hour is 325 kilometers. Then I can divide by 72 kilometers per hour. My time will be 325 divided by 72, 325 divided by 72, and I get 4.513, which I will round to 4.51. How do I know the equation or the label? Kilometers is gone, kilometers is gone. I label it hours. So in terms of what I put into the calculator, I have 325 divided by 72. If I go back and try this one again, but use my rearranged equation, I see that time is distance over speed. And interestingly enough, if you keep in mind what we just did, sorry, that was a silly mistake. time is distance over speed. My distance is 325 kilometers over 72 kilometers per hour. And again, just like with in the last example where we rearranged it after we had it done, I end up doing the same math. I end up still taking 325 kilometers divided by 72 kilometers per hour. So I still get a time of 4.51 hours. The only difference in the two methods is when you rearrange. This way you rearrange the letters first and then solve. In the other way, you put the numbers in and then rearrange with the numbers. Either way, if you're solving it correctly, you'll get the correct answer. The difference between that example and this example is now it says, how much time would it take the sound of thunder to travel 1,500 meters east? When I see that word east, I know that I now have a vector quantity, and this is just meters. So this right here is a displacement. And it says, and it's traveling at a speed of 330 meters per second east. That's not a speed, that is a velocity. So I am using a little bit different version of the equation. Again, it doesn't matter which version I use, I should be able to get the same answer. So I'm going to do the rearranged version. And if you go back up here, T is delta X over V. Just like D over V, now it's delta X over V. My delta X is 1,500 meters east. Again, I could choose to put positive 1,500 meters over 330 meters per second east. Now time, remember, does not have a direction. It only can go forward. And so it's not a vector, it is a scalar. The way that this works out in the math is that if I have east on the top and east on the bottom, the direction disappears, and that's why time is a scalar. I am also going to see that meters is going to disappear and meters is going to disappear. So I'm going to be left with seconds. So my answer, I'm going to put in the calculator, 1,500 meters divided by 330 gives me an answer of 4.545454, so 4.55 using my drop and round rules, and I'm left with seconds. And again, if I had started with the original equation, V equals delta X over T, and put things in where they belong and rearrange correctly, I would get the same answer. And that is my final example. Hopefully this will help you work through how you solve for the other variables in the speed and velocity equations.